This is Chemistry Podcast 7.2, and we're going to talk about empirical and molecular formulas. So, the definition of an empirical formula is a formula that gives the simplest whole number ratio of the atoms of each element in a compound. Basically, that's a lot of words that just say you need to take the subscripts that are in the formula and you need to reduce them down if you can. So, we have a couple examples here to help us out. The chemical formula that you're seeing right here, that is how the atoms actually go together to form these compounds. That's also called the molecular formula. So if we're thinking of hydrogen peroxide is two hydrogen atoms with two oxygen atoms. And what we can do is if we look at these subscripts, we can see that we can reduce them both by 2. They're both divisible by 2. So divide by 2, you end up with one H and one O. If I looked at the second one here, each of these subscripts is divisible by 6. So if I divided everything by 6, we would end up with a CH2O. This one, you can't divide it down. It's as simple as it'll go, so it stays the same. And then this third one, they just rearranged the formula, put all the elements together, and you can see that each of these subscripts is divisible by 2. So this would come out as CH2O. So a couple things to notice. It is okay if your empirical formulas for different compounds are the same. That doesn't matter. You cannot have different compounds if the molecular formulas aren't different though. So if you're looking at two different compounds, they have to have two different molecular formulas. But the empirical formulas can match. And also the empirical formula can be the same as the molecular formula. It doesn't have to be different. So it says determining the empirical formulas. What we do is we use a rhyme. There are 4 steps when we're trying to get from the percent composition to the empirical formula. So it's percent to mass, mass to mole, divide by small, multiply till whole. If you can remember this little rhyme, it'll really help you out in remembering the steps in the order that everything goes in when you're trying to determine the empirical formula. So our first practice problem says, determine the empirical formula for a compound that contains 2.128 grams of chlorine and 1.203 grams of calcium. So what you need to do is think back to the rhyme, and the first step was percent to mass. Well, we don't have percentages to start with. We're starting with masses. That means I don't have to worry about that first step. It's done for me. So since my masses are going to be my starting point, I have to go mass to moles because it was percent to mass, mass to moles. So my first step here is to take these grams of our two elements and we're going to convert them into moles. And to go from mass to moles, you just use the molar mass in the periodic table. Remember, we're going to ignore diatomics when we're talking about formulas. So chlorine, if I looked it up on the periodic table, is a mass of 35.45 grams in 1 mole. And calcium is 40 grams in a mole. It's just the one step. That's all you need. You're going to divide the 2.128 by 35.45 and you're going to get 0.06. Then you take the calcium and divide and you end up with 0.03. So percent to mass, mass to mole, that's what we just did. Divide by small. You look at your answers and you pick out the smallest one and you're going to divide each answer by the smallest one. So in this case, that'll be the 0.03. This will come out as 2. This will come out as 1. And then that last step in the rhyme was multiply till whole. Well, these are already whole answers. Those are whole numbers, so I don't have to do that last step. What these are, they're the subscripts for the empirical formula. And I need to look back at what I was given. Calcium has a plus charge, chlorine has a negative. So when I write the empirical formula, I'm going to put calcium first. So the empirical formula for this compound would be Ca, and there's one of them. So just Ca, Cl, and there's 2 of them. So this would be CaCl2. That's your final answer. That's your empirical formula. We're going to try it one more time. This time we're going to start with percentages. And this is unnecessary information up here. I don't care how much of that compound I have. It doesn't affect how I'm going to do this calculation. This one says I have 72.2% magnesium. So 72.2%, I'm going to assume 100 grams of the sample, because that makes my math a whole lot easier. If I assume I have 100 grams of the sample, then I have 72.2 grams because the percentage will match the grams. So that first step of that rhyme where it says percent to mass, it's as easy as taking the percent signs and just changing them into grams because we assume 100 grams, so it makes the math really easy. So we have 72.2 grams of magnesium, and then we have 27.8 grams of nitrogen. Magnesium's molar mass is 24.3, and that's in 1 mole. Nitrogen is 14 grams. So when I do the division on this one, this comes out at 2.97, and this one on the bottom comes out at 1.99. So percent to mass, mass to mole, divide by small. I'm going to divide both of them by the smallest, which is 1.99. This is going to come out at 1.5, and this is going to come out at 1. And I need to multiply until these are whole. Well, this one, if I multiply by 2, that's going to get rid of my decimal. This will make the answer 3. And what I do to one, I have to do to the other. So this is going to become 2. Now that those are whole numbers, I can use them as subscripts in the empirical formula. So the empirical formula for this compound is Mg3N2. And that's your answer for that problem. All right, the molecular formula is the last thing we need to talk about. The molecular formula is what we already showed in that table. It's how the actual atoms go together. It's how many there are of each element in a compound. So we like the empirical formula, but we'd really like to know the molecular formula so we know exactly what goes together. In order to find the empirical or find the molecular formula, you have to find the empirical formula first, and then you calculate the mass of the empirical formula. That's what this EFM is. That just means if we think back to that second problem that we just did, if our answer was Mg3N2, if I wanted to find the empirical formula mass, I would go to the periodic table and I would add up 3 magnesiums and 2 nitrogens, and I would get that total mass. That's the empirical formula's mass. They are going to have to give you the molar mass of the compound in the problem. So this will be provided in the problem. It's never something you're going to have to find. So we take the molar mass that's given and we divide it by the empirical formula's mass. That answer should come out to be a whole number. If it doesn't come out to be a whole number, you did something wrong. And then that whole number is what we multiply the empirical formula subscripts by. So it says, find the molecular formula for a compound whose molar mass is 124 grams and empirical formula is CH2O3. Well, the first step that we just talked about was finding the empirical formula. We don't have to do that. They gave it to us right here. So I can jump to the next step, which is to calculate the EFM, which is the empirical formula's mass. So if I break this down, I go to the periodic table. I have 1 carbon, which is 12 grams. Plus I have 2 hydrogens, which are each 1 gram, and I have 3 oxygens, which are each 16. And when I do all of that and I add it up, I end up with 62 grams. What you're going to do then is you look back into the problem for the molar mass, and my molar mass is 124. What you're given in the problem always goes on top. So the 124 is going to go on top. We need to divide it by the empirical formula's mass. And when I divide those, I get an answer of 2. That means that my molecular formula is 2 times bigger than my empirical formula. So I take this 2 and I distribute it to each of the subscripts that are in the empirical formula. So the molecular formula for this compound, once I do all the multiplication, is C2H4O6. All I did was I took 2 times 1, 2 times 2, and 2 times 3 to get each of these subscripts, and that would be the molecular formula. This next one, they're going to make you calculate the empirical formula first and then find the molecular formula. So it just is a combination of what we were doing in practice problems 1 and 2 and what we just did in 3. You're not given percentages, you're given masses, which means these are the numbers I'm going to start with. I have 4.90 grams of nitrogen and I have 11.2 grams of oxygen. Nitrogen is 14 grams per mole, and oxygen is 16 grams per mole. I'm converting it into moles so that I can divide by small. The answer for this top one is 0.35, and this one is 0.7. This is smaller, so both my answers are going to be divided by 0.35. This top one will give me 1, this one will give me 2. Those are whole numbers, so they become my subscripts. It's going to be NO2. That's the empirical formula. I need to get to the molecular formula though. So what I'm going to do next is I'm going to add up the mass of this. Nitrogen is 14 plus I have 2 oxygens, which are each 16. And when I do that and I add them up, I get a mass of 46 grams. They told me in the problem the molar mass is 92. So 92 goes on top, divided by the mass that I just calculated, which is 46. That gives me an answer of 2. So I've got to multiply each of my subscripts from my empirical formula by 2 to get the molecular formula. And that means my final answer here is going to be N2O4. That's the molecular formula for that compound. We are going to do one more together. So practice problem number 5. We have a compound that contains only carbon, hydrogen, and oxygen, and is found to be 48.38% carbon and 8.12% hydrogen. Well, they only gave us 2 percentages, but they said that there were 3 compounds. Don't forget that your percentages always have to add up to 100. So since they gave us 2 of the 3, the difference, or whatever is left over in order to get us up to 100%, must be the oxygen. So they said that carbon is 48.38 grams. They said that the hydrogen is 8.12 grams. To figure out the oxygen, I take 100 minus 48.38 minus 8.12, and what I'm left with is 43.5 grams of oxygen. I'm going to take each of those, even though there's 3, it gets treated the same as our other problems. We'll divide them by their molar mass. So this one will be divided by 12. This one will be divided by 1. And this one will be divided by 16. And when I do those, I get the answers of 4.03, 8.12, and 2.72. So the smallest of those is 2.72, and that's what I'm going to then divide each of those answers by. This bottom one, since it's divided by itself, is going to be 1. 8.12 divided by 2.72 is very close to 3. And this top one right here comes out at about 1.48, 1.49, depending on how you punch it in. But I want to round that to 1.5 because that is a lot easier to multiply to a whole number instead of trying to figure out what you do with 1.48. So I'm going to multiply each of these by 2 because I have to get rid of that 1.5. It needs to be a whole number. This will become 3, 6, and 2. So those are my subscripts that go into my compound up here. I'm going to end up with C3H6O2. So there's my empirical formula. My molecular formula, I need to figure out my mass first so that I can get there. If I add each of these compounds up, I end up with 74 grams. So 3 carbons plus 6 hydrogens plus 2 oxygens gives me 74 grams. They told me in the problem the molar mass is 222. So 222 divided by the 74 of my empirical formula, that gives me an answer of 3. That means I have to take each of these subscripts and multiply it by 3. So my final answer would be C9H18O6. That is the molecular formula for this compound. All right, that is it. So you need to be able to take percent composition and work your way all the way to the molecular formula if you need to. Work on memorizing those 4 steps, how you go from the percent composition to the empirical formula, and we'll do some more practice in class.